Okay, TRIG kids, this is day 3. This is last day of semester review. Make sure you have your packet filled in. We have up through like number 30, I think, done at this point. If you do not have it done, make sure you get it done. I don't know, do I have to tell Cray individually? Cray, get your packet done. I will not let you photocopy, any of you, photocopy somebody else's packet. You have to have it done by yourself. All right. So starting with 31, we're filling this in. Get your packet done. 31, we have 10 problems. They give us points and they say we're starting with M and going to P. Like this tells me that M is the starting point and P is the ending point. And they want us to write it in component form. And component form is this form, A comma B. A just tells the X direction, B tells the Y direction. So we are starting with 2 and going to -3. And if we're starting with 2 and going to -3, that means we're going down 5. So we put -5. And then if we're starting at -1 and going to 4, that means we're going up 5. Okay, so this is our component form. This is part of the answer. Then they say find the magnitude of MP. Okay, so like 5, 5, if I start at 0 and go -5, 1, 2, 3, 4, 5, and up 5, my vector looks something like this. Like this is what my vector looks like, -5, 5, right? And they want to know the magnitude of that. And so all I do is make this into a triangle right here. This is -5, this is +5, and I do the Pythagorean theorem to find out what this third side is. So 5 squared plus -5 squared equals c squared. Okay, 5 squared is 25. -5 squared is also 25. And so I have 50 and c squared and the square root of 50. Since the square root of 50 does not come out nicely, we're going to leave it as just the square root of 50, and so that will be my magnitude. Sometimes we use r for magnitude, like in polar form, we do r is the square root of 50. Otherwise, they'll write magnitude that looks like this. So like the vector, or the magnitude of that vector, we'll call it v or whatever. Is the square root of 50, however you want to write it, but the magnitude is just that Pythagorean theorem stuff. You can call it r, all right? 32, express this in polar form. Polar form is r cosine theta plus I sine of theta. So if we're given this information, we have to find r and we have to find theta, and those are the only two things we have to do. All right, we start with 3, -6. Let me just to the right 3 and down 6. And we have this dot, and we're going to do the same thing as what we just got done doing and make him into a triangle, and bow ties, not hourglasses. So we've got 3, -6. To find r, we're finding the magnitude. We're finding this length right here. So we have 3 squared plus -6 squared equals c squared. 3 squared is 9. -6 squared is still a positive 36. And that will be like 45. So the square root of 45, that's the r, the square root of 45, okay? Then to find theta, theta is this guy inside of here, and we have to do, like, find that angle. So in comparison to theta, -6 is the opposite, 3 is the adjacent. So we're gonna use tangent, like we always do, right? Let me get rid of my arrow here. Tangent of theta is equal to the opposite of -6, the adjacent is 3, and to get theta solved for, we do inverse tangent of -6/3. Now, -6/3 does reduce to -2, so if you want to type it into your calculator as inverse tangent of -2, you can do that. It doesn't really matter. And I get something like -63.4. is what theta is, -63.4, except this is in the 4th quadrant, okay? So I always like to write the angle of going from here around, and if this angle is 63.4 degrees, like that reference angle, it's 63.4 degrees smaller than 360. So I take that 63.4 and I subtract from 360. And it's going to be something like 296.6 degrees. 296.6 degrees, okay? That seems like a lot of work, but you know, like the more you do it, the easier it becomes. And this in polar form, if we write it out in this form right here, is the square root of 45 cosine of 296 296.6 plus, I'm running out of room, I sine of 296.6. Okay, close parentheses. That's what he will look like in polar form. There it is. Okay. All right, moving on to the next one. Now it says find the component form of the vector. And this is the magnitude. If you want to call it r instead of that funky, weird notation, you can. R is 7, and the angle is 190 degrees, which is in the third quadrant, okay? So they're not giving it to you in polar form, but they're basically giving you the polar form. If we write it in polar form, this is what it looks like. Like that's what they're giving me, okay? And we want to write it in component form, which is this right here, a comma b. Okay, so how do you go from this to this? We've talked about this before. Just distribute the 7 through. 7 times cosine of 190 is a, and then 7 times sine of 190 is b. You don't add them together, like that's not a thing. You don't like write it like that or whatever. That's just the separation. That's where the comma is. 7 cosine of 190, 7 sine of 190. Now, do you need to be in radians or degrees? Degrees, because 190 is a degree. So 7 cosine 190 is something like negative 6 point, I'll go 2 decimal places, 6.89, and 7 sine of 190 is negative 1.22, negative 1.22. Okay, make sure you're typing this into your calculator so that you can check this, all right? Now, before I move on, 190 degrees I said was in the third quadrant, right? Like it's down over here somewhere. 190 goes all the way around to there. If I have negative 6.89 and negative 1.22, does that an angle in the third quadrant? Yeah, they're both negative, so it's in the third quadrant, all right? So that should be consistent. Make sure your answer is like making sense with that, right? 34 is saying they want us to find TU, and they give me the component form for U and V. No, not TU. Find vector T if it is 1/2 of U minus 1 minus V. So I'm going to take half of U and subtract V, all right? Half of U, if I take half times this thing, half U is negative half comma 2. That's half of U. And then I'm going to subtract V, which is just 3 negative 2, okay? This I had more of you mess this up on the test than I should have, just because you're trying to do like double negatives. Don't do that. Be careful when you're subtracting things. This is 1/2 minus 3, right? Negative 1/2 minus 3. So that's negative 3 and 1/2. Okay, don't try to do any double negative-y things, whatever. This is just negative 1/2 minus 3. Then we have 2 minus a negative 2. Okay, there you do have a double negative, so we have to add 2 plus 2 is 4. This is what my vector T is going to look like if I combine those two together, okay? But be careful with your minus sign. You're just subtracting that number, right? That's all you're doing, okay? Find the magnitude and direction for this negative 6 plus 9i. That is exactly what we did here on 32. We did exactly that. Express that in polar form. We found the magnitude and direction. The only difference is on 35, we don't have to actually write it in this form, but you're doing exactly the same thing. You're finding r and you're finding theta. Okay, magnitude and direction. So I'm going to map this out so that we know what he looks like. Negative 6 plus 9i. And it is this right here. He's a right triangle. I'll make him a different color here. And he is negative 6 and positive 9, and that's what it is, okay? To find the magnitude, I have to do a squared, b squared, c squared, so negative 6 squared plus 9 squared equals c squared. Negative 6 squared is still 36 positive. Anytime you have a negative, it turns into a positive when you square it. Plus 81 equals c squared. 36 and 81 is 117. And then I take the square root. The square root of 117 does not come out nicely, so we're going to leave it. So the magnitude, or the r, is the square root of 117, and then we just have to find the direction, or our angle theta. Okay, and the direction is finding that angle theta. Okay, so we have opposite, we have adjacent. Opposite is 9, adjacent is negative 6. We're going to do tangent. Whoop, here we go. Tangent of theta equals 9 over negative 6. And I have to do that inverse tangent again. So inverse tangent of 9 over negative 6. And you can reduce that if you want to 3 over 2. 9 over 6 is 3 over 2. But I'm going to do inverse tangent of 9 over negative 6. And I get negative 56.3. Theta equals negative 56.3, except that's not my direction. My direction actually goes from here to here, right? So if this is 56.3 degrees, that's 56.3 degrees shy of 180. So I'm going to subtract that from 180 and I get something more along the lines of 123.7 degrees. Now you can do that, or you can say 56.3 degrees. That would be north of the west direction. Okay, 56.3 degrees north of the west direction, if you like to do it that way. That's what that looks like. Okay, 36, find the initial horizontal velocity and vertical velocity of a soccer ball that is kicked with a velocity of 77.5 at an angle of 20 degrees. Okay, let's map out what this looks like. A 20-degree angle with the horizontal is 20 degrees here, and it's going 7.5 meters per second. Now they're saying, what is the horizontal velocity and what is the vertical velocity? So like, we'll call this X and we'll call this Y. All you're doing is solving for X and Y by using SOHCAHTOA, because this is a right triangle. So horizontal velocity, vertical velocity. It's like how fast is it traveling upward and how fast is it traveling horizontally. Like you might see, I don't know, like if you were a person standing underneath of this object that was flying, you don't see it going at the angle. You see it going this direction, right? Like you just see it going in the air if you're standing a ways away from it. So like how fast does it look like it's traveling horizontally over top of you, okay? So that's kind of why that works. Let's solve for X first. So if we have that, 20 degrees is my angle, X is the adjacent, and we have the hypotenuse, which is 7.5, right? So adjacent hypotenuse, that is cosine. Cosine of 20 equals X over 7.5. And we multiply by 7.5 over, and that gives us 7.5 cosine of 20. I needed to be in degrees. So in the X direction, it's going 7.05 meters per second. Like that's how fast it looks like it's traveling over top, going horizontally. The Y would be opposite over hypotenuse, and that is sine of 20 equals X equals Y over 7.5. If we multiply the 7.5 over, we have 7.5 sine of 20, and Y will be 2.57 meters per second. So if vertically it's traveling at a rate of 2.75 or 2.57 meters per second. Now, this again is giving us basically polar form. So if you want to think about it this way, this is 7.5 cosine of 20 plus I sine of 20, right? And what you just did was you found the component form. You found 7.05 comma 2.57, which is taking this times cosine. Look at 7.5 times cosine 20, 7.5 times sine of 20. Like you just did that to find the component form. You're just doing X and Y direction, right? So either way you want to look at it. If you want to look at it in polar form, you can do it that way. But this is what it means, all right? 36 is done. Now we're moving on to chapter 12, matrices. 37, 38 are solving the system. So 37 does have a solution. And then we're going to look at 38 and figure out how many solutions that one has, because it might have something weird happening. I don't care what method you use. If you would rather use substitution, you can. I always like to do elimination. So I'm going to eliminate the X, and if this is 4, then this one has to be negative 4, so I'm going to multiply through by negative 4, okay? So I've got 4x minus 3y. I'm just rewriting the top. The bottom, if I distribute the x through, will be negative 4x. minus 8y equals 19 times 4. I can't think right now. 19 times 4 is negative 76. And then the 4x cancels. And I have negative 11y equals negative 77. And if I divide by negative 11, I get something like positive 7. Okay, last thing I have to plug back in. I'm going to plug into the bottom one. I think I'm plugging into the bottom equation. So x plus 2 times 7 equals 19. 2 times 7 is 14, and if I subtract my 14 over, I get 5. Okay, and what that tells me is that 5, 7, hey, is the coordinate where those two lines are going to cross each other. Okay, so that's what that solution does. Thank you. 38, how many solutions does this have? So not every time you do this do you get an answer like 5, 7 that comes out nicely. So we're going to do this and we're going to figure out how many solutions this has. I like to do elimination. If you want to do substitution, you can, but this eliminates really nicely. So I'm going to eliminate, like, let's say the x's, right? I'm going to eliminate the x's. So if this is 6, then this has to be negative 6. So I'm going to multiply by negative 3. Okay, so this is, I'm just going to write this right below here. Okay, so negative 3 times 2x is negative 6x. This would be minus 15y, and this will be negative 24. And if I put those together, the x's cancel, the y's cancel, so I end up with like 0 equals, and this is negative 6, I think, negative 6. And 0 is never equal to negative 6, so this gives me no solutions. And what that's going to look like is two lines that are parallel to each other where they're not touching, okay? If you had something like 0 equals 0, then you would have infinitely many solutions, right? But this one is no solutions, okay? Or you could get something really nice where you actually have an answer, and that's okay too. Like, that's fine. All right, 2 left. 39 is finding negative 3a plus 4b. So I'm taking negative 3 times a, and I'm adding it to 4b, okay? You can only add and subtract matrices if they are exactly the same size. So this is a 2-row, 3-column. This is also a 2-row, 3-column, okay? So they're the same size. We're good to go. Let's take negative 3 and multiply by all of the a's right here. So negative 3 times a is 3, negative 18, negative 15, and the bottom would be negative 6, 0, negative 3. I'm going to add that to 4 times b, which is 8, negative 8, 12. I'm trying to go fast because it's starting to rain. 0, negative 16, and 20. Then I add those together. You get something like 11, and negative 26, and negative 3, and negative 6, and negative 16, and negative 17. There's my final answer after you put them together, okay? Okay, last one, I'm gonna go really fast, so check me. This is a 3 by 2. This is a 2 by 3. And the middle two numbers are the same. So I'm going to end up with a 3 by 3 as my answer. Okay? So I'm going to write it out like this. 3 by 3. Okay? 3 by 3. All right, we start with the top row and multiply by the column. So 2 times negative 1 is negative 2. 3 times 6 is 18. Okay? So this first cell is going to be positive 16. Okay, then I go 2, 3 times 4, negative 5. That is 8, negative 15. And that answer is going to be negative 7. All right. Then I take 2, 3 times negative 2, 0 is negative 4 plus 0. So negative 4. Negative 4. I'm literally sitting here after school and it's like hailing. Okay, so sorry, I hope you can hear me in this video. I'll go really fast. Here we go. Let me just do the next couple ones. So 0, -4 times this would be 0 plus, or excuse me, -24. So -24. 0, -4 times 4, 5 is 0 plus 20. So just 20. 0, -4 times that is going to be 0 plus 0 or just 0. Last row. It would have to do this, of course. All right, I'm just going to do it quietly. Here we go. -1 plus 0 is -1. 4 plus 0 is 4. -2 plus 0 is -2. So that's what I get as an answer. All right. Check me, make sure that I'm right, because there's a lot going on over here. It is hailing and downpouring. All right. Make sure you get your packet all filled out for Monday. You guys take this test on Monday. All right.